Rotational symmetry. Our objectives for this screencast are that you can identify the order and angle of rotation for an image if it has rotational symmetry, and also to create an image that has rotational symmetry. First, let's talk about the definition of rotational symmetry. Rotational symmetry is what occurs if you can rotate an image around a center point by fewer than 360 degrees, and the figure appears to be unchanged. Sometimes it's more difficult to look at a definition in terms of words, so let's look at an example. So in our example, we're looking at an image of a flower, and when we play, it has rotational symmetry because we rotated it just slightly and the image mapped right onto itself. Let's look at that again. So this image has rotational symmetry. Let's look at some more definitions that might help us understand rotational symmetry a little better. The center of rotation is that center point around which you rotate. The angle of rotation is that smallest angle that you need in order to create a duplicate image. And the order refers to the number of rotations you would need to get all the way around to where your initial position was. So let's look at some more examples. Here we have our first example. It has order 2. Let's look why. So here we have our image. It definitely has rotational symmetry of order 2. And here we just have a mark just so that we have our orientation. So when I play this, we can see that it's rotating around not once, but twice. So once, and we have our image mapped onto itself, and then yet again, and that's where we get order of symmetry 2. So order 2 means that it took us 2 times to get to our initial position. How do we figure the angle of rotation? One way to do that is to look at, out of the 360 degrees, it took 2 tries. So if we take 360 divided by 2, that's 180. So the angle of rotation is 180 degrees. Or in other words, we need to turn this or rotate it 180 degrees for our first mapping. Our next example, this has an order of 3. Let's look at why. So this line will give us a little bit of perspective. It takes 1, 2, 3 times to get back to our original position. That's why this image has order 3. So this image has order 3. Its angle of rotation, well, out of the 360 degrees, it took 3 spins. 360 divided by 3 is 120. So its angle of rotation is 120 degrees. Our next example. What is the order and angle of rotation of the following figure? So here we have an image, and how would we figure this out without an animation to help us out? Well, the first thing I would recommend is trying to find the pattern in the image, a pattern that is repeated. So I saw this little curve. So what we're trying to figure out is how many of those curves or those little S's are there inside of this figure. So I count 1, 2, 3, 4, 5. So in this figure, I see 5 repetitions, and imagine spinning this 5 times around to get back to our original orientation. So its order is 5, and to figure out the angle of rotation, that's 360 degrees divided by 5, or 72 degrees. Let's look at our fourth example. What is the order and angle of rotation of this figure? And although there are other kinds of patterns, there is no real rotational symmetry in this figure. So you could say that it has an order of 1, or that its angle of rotation is 360 degrees, that it will take us one complete circle spin to get us back to the original figure. But that's not something that mathematicians usually say. What we might say instead is that it has no rotational symmetry. So how would we create a figure that has rotational symmetry? So let's try to rotate this first counterclockwise. So I notice that this first point, 5 units up, so I'm going to go 5 units in the 90 degrees counterclockwise. So I'm going to start at that point there. This has a slope of +1. So I'm going to want to create a line segment with a slope of -1. Going 2 down, 2 over. So I would expect my segment to land about there. For the next segment, this has a slope of -1, so I would like a slope of +1. And it looks like I'm moving back towards the center of the figure, so see, down 1 over 1. I'd imagine my segment's going to land about there. From here, I have a horizontal segment, so I'm going to want a vertical segment, probably right around here. A parallel segment. So that has a slope of -1. Again, I'm going to want a slope of +1. And then this last segment has a slope of +3/2. So I'm going to want a slope of -2/3. And we have successfully rotated 90 degrees counterclockwise. Now let's look at this original segment or original portion of my figure. Let's rotate it 90 degrees clockwise. So I'm going to start with this segment. Again, this was 5 units away. I'm going to be moving it clockwise 5 units away. This had, again, the slope of +3/2. I'm going to want a slope of -2/3. We had a slope of -1. I'm going to need a slope of +1 for the next segment. We have a horizontal line. I'm going to need a vertical line. These two lines are parallel. And then we had our slope of +1 up 2 over 2. So this time we're going to go down 2, back 2. So far we have rotated 90 degrees counterclockwise, 90 degrees clockwise. And it would be your choice if you wanted to continue moving clockwise or go back to moving counterclockwise, but with that same philosophy, looking at slope, looking at distance. And this is what our figure would look like so that it has rotational symmetry. Its order would be 4, and its angle of rotation would be 90 degrees. So in this screencast, you've learned how to identify the order and angle of rotation of an image, if it does indeed have rotational symmetry, and you've learned strategies to create an image that has rotational symmetry. Have fun!